Hi everyone, Sanbonani, Molweni, Dumelang. In this video, we will be doing the November 2020 Paper 1 exam. We'll be doing a hyperbola question 4 in this paper. And we'll start with the first question. So we're given a function, h of x is equals to negative 3 over x minus 1 plus 2, which is a hyperbola, right? This is the standard form of a hyperbola. So 4.1.1 asks us to find the equations of the asymptotes of h. Let's do that then. So remember, the standard form of a hyperbola is a over x minus p plus q. And in this case, a is equals to negative 3, p is equals to 1, q is equals to 2, right? And these dimensions are important, especially p and q, because we'll be using them to find our asymptotes. Now, let's start with the vertical asymptote, which is usually abbreviated VA. To find the vertical asymptote, what you do, you set the denominator equal to 0. So the denominator is x minus 1 in this function. 0. You set the denominator equal to 0. This implies that, so this sign, this implies that you're using when you're separating two equations, right? So usually you'd move on to the next line, right, and say when you're solving this you get x is equals to 1. But if you don't want to move to another line, you want to stay in the same line, you can use the sign. This implies that x is equals to 1. Now let's move on to our horizontal asymptote. Abbreviated as HA. For this, it's just y is equals to q. So y is equals to q. In this case, q is 2, right? So remember, for the vertical asymptote, x is equals to p. For the horizontal asymptote, y is equals to q. All right. Now, let's explain this. Why is the x is equals to p the vertical asymptote? Why is y is equals to q the horizontal asymptote? Because you might forget, right? Which one is the vertical one? Which one is the horizontal one? If you draw the line, x is equals to 1, our vertical asymptote. This is what you get. X is equals to 1 will be this line. And this is x is equals to 1. If you want the line y is equals to 2, this is what you get, and this is the line y is equals to 2. This is the vertical asymptote, and this is the horizontal asymptote, right? So if you ever think you're forgetting which one is the vertical one, which one is the horizontal one, try picturing the graph in your mind. Now, let's talk about the idea of an asymptote. Let's look at what the graph h of x looks like. Right? This is the graph. Now let's add the asymptote y is equals to 2. Is the purple line. So do you notice that our hyperbola is approaching the line y is equals to 2, but it doesn't touch it ever. Like, it just continues and continues and continues and continues and continues and continues, but it doesn't touch it, it doesn't cut it, it just keeps approaching it it gets closer and closer as the value of x decreases. Also, as the value of x increases, our hyperbola, the red graph, approaches the purple line. We're increasing the values of x. This is the x-axis, increasing, 120, 130. And we see that the purple line and the red line are getting closer and closer to each other, but you can still see purple and red. See? They're still apart. They get closer and closer, but they don't touch each other. And that is an asymptote. So, just like we saw on the graphing calculator, this is what our graph looks like. The orange line is our vertical asymptote, x is equals to 1. The green line is our vertical asymptote, y is equals to 2. Right. Now, why does this make sense? Let's start with the vertical asymptote. At the point x is equals to 1, the graph is undefined. Do you notice that this denominator at x is equals to 1 will be 0. Therefore, you'll have a fraction that is negative 3 over 0 when x is equals to 1. And this is undefined. You can't divide by 0 in mathematics. Therefore, the graph should never ever attain the value x is equals to 1. Hence, this line becomes an asymptote. X is equals to 1 will be our asymptote. Now, let's talk about the horizontal asymptote, y is equals to 2. Y is equal to 2 is an asymptote because as x grows, as x becomes bigger and bigger, like extremely big or extremely small, the part of the function, the fraction part of the function becomes smaller because you're not dividing by a big number. When you divide by a big number, the fraction becomes smaller. When you have 1 over 2, that's 0.5, compared to 1 over 10, that's 0.1. Do you notice that 1 over 2 is greater than 1 over 10 because you're not dividing by a bigger number? 10 is bigger than 2, so the fraction will be smaller. The part of the function which is the fraction, this part negative 3 over x minus 1, this part becomes smaller and smaller and smaller because the denominator keeps getting bigger and bigger. And the only significant part of the function will be 2 because this part now is becoming smaller. It is becoming closer and closer to 0 because it's becoming smaller and smaller and smaller. Right? But it'll never be 0 exactly. Hence, you're only left with 2. If this is 0, h of x will be 2. If the fraction is 0, h of x will be 2. But then the fraction will never be exactly 0. Hence, the graph approaches 2, y is equals to 2, but it doesn't touch it. Great. If you don't understand that, please relax. That's fine. As long as you know how to calculate the vertical asymptote and the horizontal asymptote, you're good. One last thing I wanted to explain. So, do you notice that this is x minus 1? It's of this form, x minus p, right? It's of this form, and that's what we want. But suppose you had, for example, suppose if this was x plus 1. Do you notice that you now have a plus? So what then? What do you do then? This is not of the form x minus something, x minus a number. It's x plus a number. So to get the value of p, you'd have to rewrite this using negatives. X plus 1 will be x minus negative 1. This implies that p is equals to negative 1 in this case.